PreCalc. This is the notes for section P2, so please make sure you write down what you need to, you follow along, you pause if you need to take a little break, and watch as often as you need to help you out. Alright, so to begin with here, we've got the Cartesian coordinate system named after René Descartes. Anyway, it should be with the look of that, with the X and Y axes. All of the vocabulary with origin is the point 0, 0. Your axes are those grid lines that kind of split everything up into quadrants. Quadrants for 4, there's 4 of them altogether. Ordered pair X comma Y, and so on and so on. There's all sorts of things to help Cartesian coordinate system. You got quadrant 1 is up in the top right corner. Quadrant 2 is over there in top left. Quadrant 3 is down there, and then quadrant 4 is right there. Some people kind of forget how that all looks and why that looks that way. One thing to kind of help you out is if you're thinking of a clock centered at the origin, centered at 0, 0, if you put where 1 o'clock is, it would be in quadrant number 1, and if you put where 4 o'clock is, it would be in quadrant. It all falls into place. Alright, so one more thing to kind of point out with that is if you're working with the coordinate system, the quadrants, the ordered pairs, X is always first, Y is always second. So in quadrant 1, it's always positive, positive. In quadrant 2, where'd that go? Gonna have to load this back up. I guess it closed on me. And over here in quadrant number 2, we're gonna have the ordered pair of X. Down in quadrant number 3, we're going to have both ordered pairs are always negative. And in quadrant number 4, we'll have X is positive, Y is negative. Alright, so we're trying to figure out what quadrant would we find these points. Point A, 2, negative 5. Since it's X is positive, Y is negative, that's going to be quadrant number 4. If it's point B, X is negative, Y is negative, it's going to be quadrant number 3. And then in point C, if it's X is 0, Y is 8, it's kind of a trick question. It's not in a quadrant at all, it's actually on the Y axis. So just be careful. Sometimes I am trying to trick you, and you never know about that. Alright, so another part right here is all about absolute value. Absolute value, another old topic. Alright, all about distance. Absolute value is a distance from 0 on a number line. Alright, a lot of people think, oh, absolute value, just make it positive and you're done. It's still technically grouping symbols. So the stuff inside of absolute values is grouping symbols, so you still have to solve that first and then apply your whole positive idea to that. So what we do is we actually think of this as grouping symbols. We want to try to figure out negative 4 plus negative 19 to begin with, and that is negative 23, and we want to apply the absolute value of that, which is positive 23. Alright, that's not too hard. And then part B. Part B, we've got negative 4 times by 3 minus 10. Think of this as grouping symbols. You can't distribute the negative 4. You've got to apply the absolute value first. So this is really negative 4 times by the absolute value of whatever's in there. 3 minus 10 is a negative 7. So you're thinking, what's the absolute value of negative 7? Well, that's positive 7. So this is negative 4 times by positive 7, which is really just a negative 28. Alright, so make sure you're doing the stuff inside of the grouping symbols first, inside of the absolute value first. And you can't distribute. Don't ever distribute inside of absolute value. Not happening. Part 3 is the distance formula. Alright, the distance formula. The distance between 2 points. On a number line, pretty straightforward. Subtract and make it positive. Alright, subtract, make it positive. On a Cartesian plane, the distance between 2 points, a little bit harder. This is a variation of the Pythagorean theorem, if you remember that from your days in geometry. Alright, so if we try this right here, maybe you might want to label x1 to be 3, and y1 to be 2, and x2 to be 6, and y2 to be 5. That's going to tell us our distance is equal to the square root of, notice how long I make that radical. It's a lot of work to go in there. This is saying x1 minus x2. So this is going to be a 3 minus a 6 squared plus y1 minus y2. That's a negative 2 minus 5 squared. If you like to switch them and put x2 minus x1 first, that's okay. That's allowed. Notice how it says that. As long as you stay consistent. You can't start with x1 and then in the second group start with y2. Not going to work. You got to stay consistent. All right, so let's actually calculate this out a little bit. P minus 6, well, that's going to be a negative 3, and we want to still square that. Plus negative 2 minus 5, that's a negative 7, and we want to square that. A negative 3 squared, that's going to become a positive 9. Notice it's a positive 9. They will always be positive at this case because you're squaring in this case. A negative 7 squared is a positive 49. If you add 9 and 49, you get 58. And the square root of 58, if you want to round that, that's approximately 7.62 in that ballpark. Or you could also simplify if you wanted to. Leave it as an exact answer. Midpoint formulas. Midpoint formulas. Pretty much what's smack dab in the middle. The exact halfway point. You add the two values together and you divide by 2. And that's basically how you find midpoints for everything. Another application that you'll see as we kind of progress through are the diagonals of parallelograms. All right, because diagonals of parallelograms bisect, meaning they meet in the midpoint. We can use that idea, that concept with a midpoint formula. So find the midpoint, 6, negative 7, and negative 2, negative 15. Maybe you might want to label this guy as maybe like x1 and a y1, x2 and a y2. You add the x's together, so we've got a 6 plus a negative 2, and then divide it by 2. You add the y values together, negative 7 plus negative 15, and then divide by 2. So if we were to actually do that, we can say 6 plus a negative 2, well, that's going to be a 4. 4 divided by 2 is a 2. And then over here, negative 7 plus a negative 15, that's a negative 22. Take that and divide by 2, and you're going to get a negative 11. So your midpoint, where these 2 points would completely have the halfway point, would be a 2 and a negative 11. All right, not too shabby. Add them up, divide by 2. The equation of a circle, the fifth topic of this little section here. Equation of a circle is another variation of the Pythagorean theorem. But this time we're going to leave specifically x to be x and y to be y. We have a center. A center is at the location h, k, and we have a radius, which is just r. So they tell us x minus h squared plus y minus k squared equals the radius squared. So knowing that, if my center is at negative 5, 0, that tells me my h value is negative 5, and my k value is 0, and my radius is 6. So if I substitute that into my equation to try to figure out what the formula of this circle would be, what the equation of the circle would be, I would say x minus negative 5 squared plus y minus 0 squared equals 6 squared. And if I clean this up a little bit, x minus negative 5 is really x plus positive 5, still squared. Y minus 0, that's just y. I don't have to change that around at all, so that's just plus y squared. And then 6 squared, I can simplify that to be 36. That's the equation of that specific circle. Center at negative 5, 0. Radius at 6. All right, how about the other one? I give you the equation. I want you to try to figure out what's the center, what's the radius. All right, so in this case, the center, notice it's x minus some value 7. So that tells me the h value is 7. And over here, it's y, well, it's y plus 4. Well, plus is really minus a negative. So couldn't this be y minus negative 4 is really y plus positive 4? Sure. So that means the k value has to be negative 4. So that tells me my center, if I could spell center, come on, Mr. Wagner. The center is at 7, negative 4. Okay, all right, that makes sense. How about the radius? Is the radius 41? No. 41 is really the radius squared. So to figure out the radius, you'd have to square root both sides. So the radius is the square root of 41. Oh, I don't know what that is, but you could use a calculator to approximate that. That's approximately 6.4. So you can find the center, you can find the radius if you're given a particular equation. Now what we could do is we could expand on this a little bit more, and we could give you just the endpoints of a diameter. and then you could have to try to figure out what exactly is the equation from there. So you really got to think a lot, use a lot of these steps about distance, about midpoints, kind of go from there. Last thing here, number 6, verifying right triangles. Alright, so the converse of the Pythagorean theorem is what you're going to be using here. So remember the Pythagorean theorem, a squared plus b squared equals c squared. So what I'm asking you to do here is verify that this is or is not a right triangle. So what I would do is I would kind of label each one of these points. One of them is going to be point A, the other one's going to be point B, and the third one's going to be point C. And what you want to do is you want to try to find the distances between all of those points. So maybe we'll start out with trying to find the distance from A to B. That's the trickiest one, from A to B. So the distance from A to B is going to be the square root of, we might say, a -2 minus a 2 squared. If you're wondering how I'm doing this, I'm just using the distance formula from earlier in the video. Plus, if I subtract the y coordinates, that's going to be a 5 minus 2 squared. And if I clean that up a little bit, that's going to be the square root of a -4 squared plus, let's see here, 5 minus 2, that's a 3 squared. All right, so that's going to be the square root of 16 plus 9. Square root of 25 is just 5. So there's one distance. The one of the distances is 5. Okay, find the distance between, pick another set of 2 points. Maybe let's go with B and C. So the distance from B to C, I'm going to go the square root of, this is going to be 2 minus 0 squared plus, well, another 2 minus 0 squared. All right, so that's going to be 2 minus 0 is 2 squared, and 2 minus 0 is another 2 squared. So that's going to be 4 plus 4 is the square root of 8. And the square root of 8, if you simplify this in radical form, that's going to be 2 root 2. All right. And then the last one maybe we've got to work with A and C, the distance between A and C. All right, so that's the square root of -2 minus 0 squared plus 5 minus 0 squared. All right, so that's going to be square root of -2 squared plus 5 squared. And that's a 4 plus a 25. And that's going to be a 29, the square root of 29. And that doesn't simplify at all. So I'm just going to kind of leave that alone. I'll leave that alone. All right, so then from here we want to see, does the Pythagorean theorem hold true? Can we work with the Pythagorean theorem here? So Pythagorean theorem, we're going to have to figure out what's the short leg, what's the long leg, and then what's the hypotenuse. So out of these 3 distances, which one is the shortest, which one's the longest, and which one's going to be the hypotenuse? All right, so that's the thing that we're going to have to try to figure out here. And the nice thing is you can try to compare them just by looking at the square roots. The square root of 25, the square root of 8, and the square root of 29. Oh, that makes it a little bit easier now. Now we can see the hypotenuse. The hypotenuse is really the square root of 29. And then the short leg, that's going to be this the square root of 8. And then the long leg is this square root of 25. So that makes it a little bit easier to kind of figure out which one is big, which one's short, which one's medium, that sort of stuff. So Pythagorean theorem says if this technically holds true, I can take the short leg squared plus the long leg squared and set it equal to the hypotenuse squared. A squared plus b squared equals c squared. So that's going to be, let's see here. I'll just use the square root to make this so much faster here. The square root of 8 squared plus, take a look at this, the square root of 25. Oh, yeah, squared equals the square root of 29 squared. So you kind of see, I could have used 5, but I don't have to, because what I can do is I can just square root, they drop out. So this is 8. Square root, they drop out. This is 25. Square root, they drop out. This is 29. 8 plus 25 equals 29. No, it doesn't. 8 plus 25 does not equal 29. Does that mean I made a mistake? No, that means I verified that this is not a right triangle. So that's what you're doing here. If you end up with this technically being a true equation, you've got a right triangle. If you ended up with it not equaling out for the Pythagorean theorem, you don't got a right triangle. Sorry on that one. All right, so that's it. That's this section. Feel free to rewatch this as many times as you need to really kind of sink in. Take those notes, summarize them, and I'll see you next time. Bye-bye.